Okay, guys, today we'll go through the review for the final exam. There is a video there in iCollege already posted and telling you about the details of this lab final exam, correct? So let's start with the most difficult part of the final exam. The most difficult part of the final exam is, write it here, is the stoichiometry, the mole ratio calculation. So this is CHEM 1151 lab final exam. So first topic here, you have to look at the stoichiometry. Stoichiometry. And this is really means mole calculations. So for example, I can give you an example. Zinc solid plus oxygen gas give you zinc oxide, correct? And if you balance this equation here, you have to add, sometimes the equation will be given to you, sometimes you have to put the equation here. So you need 2 here in front of the zinc oxide and 2 in front of zinc. So that now we have balanced equation. Why? Because you have 2 here of oxygen. So this is a balanced equation. So it will tell you that oxygen from the air in abundance, this will be in excess, and this will be limiting. So it's not in excess. So if I give you 35.5 grams of zinc, the question is how many grams of zinc oxide? How many grams of zinc oxide? How many are obtained? So let's solve something like this. We have zinc limiting, will be consumed 100%, and you have 35.5 grams of zinc, and we want to see how much is this zinc oxide you will obtain. So in order to get through this, we have to put the balance equation, and we have to know first the mole to mole ratio. So 2 moles of zinc will give you 2 moles. 2 moles of zinc will give you 2 moles of zinc oxide, correct? Then you need the atomic mass. You have to convert this one here, the grams of the limiting reactants, which is zinc, has been converted into moles. How I do this? I have to use atomic mass of zinc. Atomic mass of zinc, correct? What's the atomic mass of zinc? Well, you have to look, the periodic table will be given to you. And let me see, zinc is 65.58. So could you verify this? So 65.5, so I would say 66. Even I take the error itself, okay? So this is 65.5 gram per mole, okay? So the next step is take those grams, 35.5 grams, with the help of the atomic mass and convert them into moles, correct? So I think you have this one here. Let's go for the second one. I have to take this one here out and start a new one. So here it is. We have zinc plus oxygen to zinc oxide, correct? 35.5 grams. This one we don't know. So grams of zinc oxide will equal to 35.5 grams of zinc over 1. I have 65.5 grams of zinc per 1 mole of zinc. Next, I have to look at the mole ratio of zinc oxide to zinc to zinc oxide. So here is, I have 2 mole of zinc to 2 mole of zinc oxide, correct? Now, if you look at this, before we get to the last step, let's look at this. Very nicely, the units are cancelling themselves out, grams with grams of zinc, mole of zinc with mole of zinc out. Then we have to we need the molar mass of zinc oxide. So here it is, zinc oxide. Zinc is, we say, 65.5, and oxygen is 16. So this one here will be 5, 1, and then 7 is 8. So multiplied by 81.5 grams of zinc oxide per mole of zinc oxide. Again, we are dealing with unit cancellation, moles of zinc with moles of zinc, 2 with the 2 cancels out. So now this will abbreviate, will be let me just do it here. This one will be 35.5 over 1 over 65.5, and then you have 1 over 1, and then we have 81.5 over 1. So we have to multiply this by this. We divide them by, at the bottom, 65.5. And the answer has to be rounded to how many sig figs? So the answer has to have how many sig figs? 3 sig figs, correct? All those are 3 sig figs. So if you have a calculator, you can calculate, tell me how much, what's the value of this? So quick. So tell me what's the value of this, please. So we can put it and then see how much. So that's one of the most difficult part of the exam itself. So we have to know how to deal with. So how much is it? 35.5 multiplied by 81.5. Maybe I can do it here for you guys. So 44 point, let me see. 44 point what? 17 grams, correct? This is a fourth significant figure. I need, this is 3, correct? 3, so it will be, the answer will be 44.2 grams. 3 sig figs. 3 sig figs. Correct? So those are the questions we are expecting. That's one of the most difficult part of the whole exam, I guess, because it's just a lot of calculation when it comes to mole ratio. Now, the second topic is Le Chatelier principle. So you have this, you have it already there, you can see it. So let's go and look at Le Chatelier principle. So I'm taking this one down, and this one will be recorded, so take this one down here, out. The second topic is, we'll go and look at the Le Chatterley principle. So Le Chatterley principle is the equilibrium. If you have a chemical equilibrium and you put stress on one side of the equilibrium, the equilibrium chemical reaction will readjust itself and moving towards the place or towards the direction with the least stress, with the least stress, with the least overload, with the least harsh conditions. So to reestablish itself. So, for example, let's get one of the example here we did in the lab. If you recall this, we have cobalt nitrate. If you recall this, correct? That was a pink, and we added HCl to this, correct? And then this one came out to be cobalt tetrachloride here, 2 negative. That's a blue solution, plus 4 of those here, plus 4 H plus 4 NO3. So this is colorless. So this part here is blue. This solution is blue. This is blue here. And this part here is, don't have pink color here, but this is pink here. So now this reaction is, if we looked at the whole thing, the heat will be at the left. So this reaction is endothermic reaction. Now the question is, what will happen if you add heat? That's extra heat from external source, not the heat inside within the system itself, but from outside. So adding heat. Number 2, removing heat. So removing heat means cooling. Adding heat means heating. So you tell me about the shift. So shift will be where? Shift will be where? If you add heat, the shift will be to the left or to the right. Remember, all this one here are called the right. Everything here, right. Everything here is left. So when you add heat, where will be the heat? To the right, correct? To the right. Shift right. What evidence you will see? More blue color, because that's the blue color in the right side. More blue color. That's your evidence here. That's your evidence. So if you cool here, what will happen? You are removing the heat. Where will be the shift? Okay, shift will be to the left. Shift left. And evidence will be more pink, correct? More pink color. And you can add to this, what will happen if you add more HCl? What will happen? That's not here, but if you add more HCl, where will be the shift? You add to the right, because HCl is already here. When you add more HCl, you more stress on the side where you added, where HCl to be found in. Where is HCl found in? It was found, or it is found in the left side. So the shift will be to the area where the least stress. So it will be to the right. Removing HCl. If I want to decide to remove HCl, where will be the shift? To the left, correct. Adding cobalt nitrate will be to the right. Removing cobalt nitrate to the left. You get the idea? So that's one topic here. Okay. Okay. Next will be the percentage calculation. We are calculating the percentage. Can I take this one out? Okay, so let's take this one out. The next topic is the type of concentration we are dealing with is mass over volume percentage, correct? That will be mass of the solute divided by the volume of the solution. This is grams, correct? This is milliliter. And the whole thing here is multiplied by 100%. Okay. Then we have mass over mass percentage. Well, it turns out to be mass of the solute every time divided by mass of the solute plus mass of the solvent. This is grams and this is grams. And the whole thing here multiplied by 100%. Okay, guys? Then we have volume to volume percentage, correct? So this one here will be volume of the solute divided by the volume of the solute plus volume of the solvent, and this one multiplied by 100%. So you have to memorize those three laws here, because that will not be given to you. So you are ready to implement those, and you can do those together, correct? So let's look at the one of them. I mean, it's up to us, whatever we can. Which one you like to see an example? We'll take one example of, not of each, just one example of one of them. Which one? Mass over mass, volume over volume, or mass over volume? What's that? Mass over mass. Okay, so you have this already. So I'll take this. Yeah. Okay, so we'll take mass over mass. So we have, okay, so what I will do here, I'll just take this one here and then just, what's that? Yes, but I will keep this one here just for to use the law. The law, we can see the law here. That's what I would like to see here. So we are taking this here. You want mass over mass. So mass over mass, we'll use this, the middle one, not mass over the volume, not volume over the volume. So I'm just keeping the one in the middle, taking this one out. Okay, so almost done. So in this mass over mass, will give you the mass of the solute that will be given to you. So it'll tell you the mass of, we have sodium chloride. Will not tell you that's the solute. Tell you sodium chloride is, say, 25.5 grams, and the H2O, or whatever this H2O is 250.5 grams. So you know by the this is small amount. This is your small amount, correct? Will not tell you this is a solute or the solute. You have to figure it out. This is small amount here. So this will be your solute, correct? This is large amount. So this one will be your what? Solvent, correct? So that's, you have to figure this one out by yourself. So you look at the amount. The least one will be your solvent. So the least one will be your solute. The larger amount is your solvent. So now here, because this is very crucial, because this is the top. So the top is 25.5 grams, the small amount. Then the solute is 25.5 grams plus 250.5 grams, and the whole thing multiplied by 100%. Correct? And you can tell me how much is this? Tell me how much is this? Tell me how much is this? How much? And let's see, same problem here. We have to look. We have to look at the sig figs, correct? So how much is the whole thing? Yes, 3 sig figs. Yes. How much is this? 9.24%. Okay, that's 3 sig figs. Because this is 3 sig figs, correct? And this one here, if you add them up, will be two. If you add those up here, will be 550, correct? One digit after the decimal because you are adding up. One digit after the decimal. Then you have 0 and 0 and 5 and 1 there, 6. Correct? Tell me if I'm wrong. And this is 7. This is 7. This is 2. Is this correct? The addition? Yeah. So that will be four sig figs. This is 4 sig figs came out after we implemented the addition rule. We are looking at, when we add, we look at the digits after the decimal. One digit after the decimal. Correct? We have one digit after the decimal, 0. Correct? And then you have 3 sig figs here, 3 sig figs here, and here it turns out to be 4 sig figs. So your answer has to be what? 3 sig figs. So this is 3 sig figs. Correct, guys? So let's look at the next topic. As I said, I'm recording this, so can I take this one out? Take it out? Okay, so yeah, don't worry, you will see this one here in a video. So the video will be how much we cover. We'll cover all the content of the final exam, so you know what to study from. So let's take this one out, and we have to look at the next topic is buffer solutions. So we said solutions that resist any change in the pH of the solution, the pH of the solution. So you add this one here to maintain the pH constant. They are added to the solutions to maintain constant pH. So buffers are added to solutions to maintain constant pH. So to maintain the acidity and the basicity of a solution, really both acidity and basicity are not changing. They are kept constant. So that's a buffer solution. Now, if the next step is if you are asked what they are made from in a question, so but in the way is giving you compounds together to see what they are made of. So can I take this one out? Can I take this one out? Okay, let's take this one out. Buffers here are made of one opportunity is weak acids plus beta there plus their conjugate bases, or weak bases plus their conjugate acids. So if I have, for example, let's look at the acids here. Acids, for example. So let's look at examples here. So if I have HCl, that's an acid combination with sodium chloride. This the chloride's conjugate base of the HCl, correct? But is this a buffer or not a buffer? What do you think? Not a buffer? That's correct. Why? No, because HCl is strong acid. Correct? It has to be a weak acid. So sodium hydroxide strong base, Drano, correct? In a Drano. And HCl is found on this cleaning of the toilet. Most of the cleaning chemicals inside the toilet, they have HCl. Again, it's concentrated as well, like Drano, correct? So if I have sodium hydroxide, correct, that's and I will say, okay, I have then I have sodium hydroxide, then I have the conjugated acid for the H, maybe H2O. Well, you have the conjugate base, but you have this one here, strong base. This is strong base. So that's not a buffer. Not a buffer. You have both the acid and the bases you use are weak. They have to be weak, correct? So let's look at some examples of the weak acid, weak base, for example. Can I take this one out? Everybody has it? Everybody has it? Okay, let's look at this. If I have something will be looking like acid, for example. Acetic acid, we did this one, the titration. That's a weak acid. And I mix this one here with sodium acetate. This is the acetate itself is a conjugate base. Sodium just has nothing to do with this. Sodium ions are spectator ions, are spectator ions. Has nothing to do with the reaction. They are watching inside. They are the solution, but they have nothing to do with this. But the buffer is made really from this and this. Weak acid and weak base. Weak acid and its conjugated base. Now, if I have ammonia, correct, that's appendix, correct? And I have ammonium. And the chloride ion is again ions. Sodium ions are spectator ions, and the chloride ions are spectator ions. They have nothing to do with the buffer. The buffer is made of both the weak base, ammonia, and this is conjugate acid of the base, conjugate acid of this base, correct? So if you have this combination, then you have a buffer. Otherwise, you don't have a buffer if you have a strong acid. Are you following me here? So that's the difference here. So anytime you have a weak acid, then yes, then you have a buffer. If you don't, then you don't have a buffer. So that's a buffer one. And let's go for the next one. Next one is balancing chemical equation. That will come. Balancing chemical what? Equation. So that has to come even in the lecture as well. So let's look at this. Can I take this one out? Okay, balancing chemical equation. So let's take one of the difficult one. So balancing not nuclear. We don't have nuclear lab, so we have just chemical reactions. So we are dealing with the balancing chemical equation. So I'll give you one is a difficult one, and see how you will do in this. So I have C10H. Let me see here. Okay, so C10H22 plus oxygen will give you CO2 plus H2O. So you have to come up with the coefficient here, 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 and here. So to balance, this is not balanced. So what are those coefficients? So, well, again, when it comes to balancing chemical equations, there are no rules. The whole idea is to maintain the number of atoms of each element at the left reactant side has to equal number of atoms at the right side, the product side. So what the next step you think it can be? Carbon here is 1 and here is 10. So my intuition will tell me, how about adding 10 here? Correct? By this, I got the carbon and carbon done. Okay? Hydrogen is 22 at the what? At the left side. And 2 at the other one. So I put what here? 11. Right? 11 multiplied by 2 is what? 22. By doing this, I have a problem with oxygen. I leave oxygen all the time. Whenever you have oxygen, nitrogen, diatomic molecule, keep it at the end. If I have nitrogen, I'll keep it at the end. If I have ozone, I'll keep it at the end. I'm not touching. I'll just add with the real molecules, the bigger one. Leave the smaller molecule at the end. Oxygen by itself here is 2, correct? How much is here? Oxygen is 20 here. And here is 11. So how much is it? 31. Well, I don't have. I have 2 here. So this is an even number. This is an odd number. When I have an even number and an odd number, this is 2 here. Even 2 is even, and the 31 is odd number. So the rule is you have to go through fraction. you have no other choice. So the fraction is to get the 2 out of your way so you get even one. So they put the top one, the bigger one, up, and the bottom one is whatever the number here, 2. So the 2 with the 2 cancels out, correct? So now, this is 1 here, correct? Nature will tell you, I'm not supporting any fraction. There is no fractional atoms, or inside the atom, there is no fractional value of the protons or neutrons or electrons, correct? So I want to get rid of the 2. So I multiply the whole equation by how much? By 2. So now the equation will look like this. 2C10H22 plus 31 over 2. 2 with the 2 cancels what? Out. I have 31O2. 2 multiplied by 10, 20 CO2 plus 2 multiplied by 11, 22 H2O. Now balance it and see if it's balanced. Let's look at this. Let's start with carbon. Carbon is 2 multiplied by 10 is 20. Oops, sorry. That's 20. Then here how much we have? How much? Correct. We have 20, correct? So that's balance here. So carbon is good. Carbon is good. Hydrogen is how much? 44. 22 multiplied by 2. This 2 here, you have to multiply all those together. So hydrogen is 44. Hydrogen here is what? 44, correct? 22 multiplied by 2. Everybody following? So hydrogen is good. Hydrogen is good. So now the problem is oxygen. Here 31 plus multiplied by 2, how much is it? 62, correct? Now here 20 multiplied by 2, that is 40, plus 22 plus 1 is 22. So how much is this? How much? 62, correct? This 62, this is 62, this is balanced, this is balanced. So the equation is balanced. So now what coefficient we are dealing with? What coefficients are dealing with? Coefficient, ratio, and now you might ask about this. This is 2 here, 2, 31, 2, 20, 2, 22. So this is coefficient ratio, or sometimes called mole ratio. Mole ratio or coefficient ratio. So 2 to 31 to 20 to 22. Make sense, guys? Make sense? Okay, that's good. So let's take this one. Take time to just write whatever anything you want. Okay, then we'll take we balance equations. That's good. And we'll do some titration. So let's do some titration here. Okay? So we'll do titration here. Everybody has this? Everybody has this? Okay, good. So let's take this one out. And then let's take the next topic. We'll do titration. In the titration questions here, I can give you acetic acid with the same one we had it in the lab, or I give you another type of acid and base. So if you want to take acetic acid, correct? Acetic acid titrated against your sodium hydroxide. So the molarity of sodium hydroxide is 0.105 molar, correct? And you are taken is 2 mL of acetic acid, correct? And the endpoint, at the endpoint, you have consumed 15.5 mL of sodium hydroxide. The question is, what is the molarity of acetic acid? So we titrated in the bread sodium hydroxide. That's the molarity of it against 2 mL of acetic acid. The endpoint was recorded at the average, of course, of different trials, is 15.5 mL of sodium hydroxide used to reach the endpoint, because you use what? Phenolphthalein, remember? So as an indicator. So now, what is the molarity of this? Well, it turns out to be, we can calculate the whole thing, and we have to know this 1-to-1 ratio. So first of all, you know the reaction is 1-to-1 mole ratio. Acetic acid plus sodium hydroxide will give you sodium acetate, that's double displacement, plus H2O. So plus H2O. So the OH here will take the H here of the acid to make H2O. That's here H2O. Correct? Then sodium acetate is the salt. So if you look at the whole mole ratio here, it is 1 mole to 1 mole. Correct? So the molarity here will be, you have the molarity is given to you 0.105 mole of sodium hydroxide per liter of sodium hydroxide. Correct? You can do a table if you want table. Let's do table. We're switching here. Now, I have to get rid of the mole of sodium hydroxide and liter of sodium hydroxide. I need the molarity here, mole per liter acetic acid. So how we do this? So first of all, I have, this one has to be converted into liters, correct? So multiplied by the liters of this 0.155, correct? Liter sodium hydroxide. So now see how nicely is the units are cancelling themselves. Liter sodium hydroxide, liter sodium hydroxide cancel themselves out. I have to look at the equation then. From here, I have 1 mole of this to 1 mole of this. So I have here, next, 1 mole of acid to 1 mole of sodium hydroxide of the base. So then you have here again, see how nicely the moles are cancelling themselves out. So mole sodium hydroxide with the mole cancel themselves out. I have here mole. I need the liters of sodium hydroxide. So the fourth step here, I don't have space for it here. The fourth step will be, last step here will be 1 over liters of the acetic acid, which is 0.00200 liter, 3 sig figs, correct? That's 3 sig figs here. That's here. It's not want to write because so then I have at the top is mole, at the bottom liter, correct? Now you calculate the whole calculation will be, look at the calculation will be, everything is just here, the top mole and the bottom is liter. So you will have, if I look at the whole thing here, let's put it here somewhere, another color, maybe blue color. So I have 0.105 multiplied by 0.0155 multiplied by 1, and then the whole thing here divided by 0.00200. This is mole, this is liter here, mole per liter. So how much is it? Somebody has it? Somebody has it? 0.105 multiplied by 0.0155 multiplied by 1, of course, divided by 0.00200 liters. So how much is it? And how many sig figs we are dealing with? 3 sig figs, correct? All those are 3 sig figs. This is 3 sig figs. This is 3 sig figs. This is 3 sig figs. Correct? So, how much is it? Somebody has it? Somebody has it? 0.814. The 4 we don't need it, just 1, because 3 sig figs mole per liter, or just replace this capital M, or replace this one here with molar. So all those the same units for the molarity here. Okay, so this type of calculation will come in the final exam. So we'll be ready to calculate the molarity, correct, guys? I hope so. Okay, so now we'll switch to the pH of the solution. You have it here? Okay, let's switch to the pH. Well, I will give you the solution, say solution, and then we'll determine the pH. An acid HCl, correct, has the concentration of 0.525 capital M mole per liter. We need to get the pH. What is the pH of this? That's a concentrated acid, will be minus log, the H, correct, plus, will be minus log 0.525. So how much is it? That will be the HCl, correct? So how much is it? This is 5, yeah, sorry. It's supposed to be 5. So how much is this? Don't worry about the minus. The minus will just vanish with the other minus of the log. Log 0.525, how much is it? 0.28, and how much after that? 279. Okay, 279. Now you have to look at the sig figs here. Okay, the sig figs will determine the digits after the decimal. I have 3 sig figs, so I have 3 digits here. 3 digits here responding to 3 sig figs. So if there are 2 sig figs here, so there will be 2 digits after the decimal. If I have 5 sig figs, there will be 5 digits after the decimal. Make sense? That's unique for the pH because it's a log. The log rules of the pH is different from the normal significant figure rules. That you are always observe the number of the sig figs you are dealing with, when you take the log of it, then whatever the digits after the decimal will correspond to the number of the sig figs. So I have 3 sig figs, so I have to have 3 digits after the decimal. Here's the decimal here. This is my decimal here. Okay, guys, let's do a base. And you tell me, okay? So can I take this one out? Okay, can I take this one out? Everybody has it? Okay, let's take this one. We'll take now the same thing, but we'll take concentrated, not concentrated, but strong base, and we'll take the same concentration. What's the pH of this? That's the tricky part. That's what? That's the tricky part. So this one here, you cannot take just direct the pH. So we are looking for the pH. So I cannot say the pH of the solution is this value. This is a base, correct? Strong base. So the value will be, I have to get the value of this, because this is a base, will be POH. This is a base here. So I'm determining the POH of this minus log 525 molar. So this is, okay, so how much is this? Came out to be point what? 279? 279, correct? However, we know that's the rule. I want you to memorize this for yourself. The pH plus the POH is 14 point whatever number. Do you have 3 digits here? Leave it this like this. So, for example, 14.0. Now I need to get the pH, but I have the POH here is 0.279. Correct? So will be, the pH will be what? Somebody will tell me what? pH is 14.0 minus 0.279. Correct? Here I have 1 digit after the decimal. Here I have 3 digits after the decimal, 1 digit. And here 3 digits. The winner is 1 digit after decimal. So 14.0 minus 2.79, how much is it? 13 point what? 7. And that is 1 digit will be the winner. And this is the pH really of a base, 13. Remember, from 0 to 6.4, that's acidic. Then 6.5 to 7.4, that's neutral. 7.5 to 14, 7.5 to 14, this is 5 here, to 14.0, that's base, basic. Correct, guys? So 13.7. So the answer is 13.7. Now you have to watch. Whenever you get the sodium hydroxide, the base, you cannot take minus log. No. The minus log you get, that's a POH. What? POH. The negative log of the concentration of the base. You get this value, subtract this one here from 14. Because this is a low here. pH plus the POH will be 14.0. Correct, guys? So, guess what? We did most of them. Okay, so remember the reaction we took a couple minutes ago? What type of reaction we did? If you recall, let me go back. This is, maybe we have to know the type of reactions we have, correct? So if I have just a simple one, you have this, can I take this one out? So let's take this one out and then see type of reactions. Now we have single displacement or replacement, double displacement or replacement, combination or called synthesis. Then we have decomposition, and combustion, correct? Now, if I'll tell you, give you whatever the equation is, CH4, that's methane here, plus oxygen, CO2, plus H2O. What type of reaction is this? I mean, we can balance it. This is oxygen is 3 here, correct? That's 3. And you have carbon, you have 2 here, correct? 4. This is 4 here. So 2 and 2, 4. This is 2. So it's now 1 to 2 to 1 to 2. But what type of reaction is this? What's that? Combustion, correct? Combustion reaction. So again, we have combustion, that's 1. We have then the rest of this is single, replacement, or displacement. Then you have double, replacement, or displacement. You have combination, or called sometimes synthesis. And the last one is if you can combine, you can decompose, correct? Decomposition. So here is 4 and here is 1. Total how many? 5 types. So you'll be ready to distinguish between the 5 ones. So you'll be able to distinguish between the five one. So, any question you have? Any question? Any question? Okay, guys. So we'll go for Lewis dot structure, the last Lewis structure, and we'll determine the Lewis dot structure and the shape. Correct? So let's do this. Can I take two now? Okay, now we'll do the whisper. So I have a compound that has PCl3. I want to determine first total valence electron VEs. How many total I have? That's I have to determine, correct? Then I have, after total, I have to draw Lewis dot structure. And then I have to do the whisper shape of the molecule. So those are three items we have to look into the final exam. So let's do it together. What is the total number of valence electrons? So phosphorus, where is valence electrons are number of the group, correct? So the VE, valence electrons, equal number of the group, correct? Phosphorus in what? Underneath what? Nitrogen, correct? So, I mean in the group of nitrogen. So this is 5. 5. Plus chlorine, where is it? 7, correct? The 7th group. So 3, that's the 3 here, multiplied by 7. So I have 5 plus 21. How much is it? 26 total VEs. Correct? So the total VEs is 26. How we get this? We get this from the fact that the VE, valence electrons, are always represented by the number of the group. Phosphorus group number 5, so it have 5 VEs. I have 3 chlorine. Chlorine, the 7th group, multiplied by 7. So 3 multiplied by 7 is 21, plus 5 is 26. That's the total number of B's. Now the question is, we have to draw that Lewis dot structure. I did teach you that anytime you have electronegative atom with large number, you don't put them together. So I cannot put here it is like this. That's wrong, because the electronegativity of chlorine, they will fight each other. This molecule cannot be stable. Only cannot be, present or exist at all, because you have 3 electronegative atoms. Those are large electronegative atoms, and put them together, they'll start fighting each other. The best thing is to keep them what? Spread out. Correct. So then the chlorine will be here, the other chlorine will be here, the other chlorine will be here. Just spread them out. Those are electronegative atoms. They cannot be together. Then you have 5 electrons for phosphorus and 7 electrons for chlorine. So let's start the chlorine. 2, 2, 2, 2, that's 6, 7. And here's 7. Here's 7. So phosphorus has 5, correct? So I will do here 1, here 1, and here 1. And then the 2 will be there in the top. They are not bound. So they are lone pair set, lone pair. They are not bonding. Why I'm doing this? Because I want to make a single bond. So single bond here, single bond here, single bond here. So this is the valence electron of BCl3. Correct? Now, what is the shape of this molecule? Well, it turns out to be, this is my A, central atom. This is B, terminal. This is B terminal. This is B terminal. And this is E, lone pair. So this is A, B3, E, 1 lone pair, 1 set. You have to memorize that table I gave you, about 5 rules there. So if I have A, B3, E1, correct? That will be what? Trigonal pyramid. So this one I can't help you. You have to memorize the those tables. Remember the chart I gave you with all this Whisper code. Look at those there in iCollege. They are there. So AB3E1 trigonal pyramid. Now, if I ask you, is this polar or non-polar? Just for the sake of this, polar or non-polar? What do you think? It has to be polar. Why? Because the presence of the lone pair. So here we have lone pair, correct? So that has to be blindly, just has to be polar, no other choice. So this molecule is polar because of the presence of the lone pair at the central atom. Correct? The angle you don't have to worry about is it's a crooked of the tetrahedral. It's not a tetrahedral per se, but it's trigonal. In the base is trigonal triangle, and then it's like a pyramid in the top. So it's a combination between triangle and tetrahedral. So it's a trigonal pyramid, and the angle will be around maybe 107 degrees. You don't have to memorize this, but at least nobody will ask you about this question, but at least you get the idea. It's like ammonia. This one's like ammonia. If you recall ammonia here, can I take this one out? So if you recall ammonia here, lose that structure of ammonia. Ammonia has, that's the last, the Lewis dot structure of ammonia. A, B, 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 and E. So this one A, B3, correct? 3 B's, and E 1 lone pair set. This is again will be trigonal pyramid, or sometimes just pyramidal. So trigonal pyramidal or pyramid. So, and the polarity, yes, it has lone pair. So that's polar here, and the angle is around 107 degrees. So between this angle here, between this and between those here is 107 degrees. Are you following me here? So I think we covered all those here, and we covered that structure. The last one. Then we'll go for density, correct? And determining sig fix. So density and sig fix. Density. Well, can I take this one out? If that's it. So we'll go for density. Now the density is very unique. In matter of fact, density is if you can say this D here will be mass over the volume, correct? This is M over V. So D is equal M over V. Now out of this I can determine what? Two sub-formulas, correct? Well, I can determine this mass is D multiplied by V. That's another formula, sub-formula. But this is the major one. This is the major one. That's the essential one, the major one. And those just two sub-formulas here. I have volume is, correct, mass over density, correct? So those are two sub-formulas and one major one. So let's look at example. I will ask you, for example, I can give you the density, I can give you the volume, and you can determine for me the mass, correct? So let's do this one here. So everybody has this? Okay, let's take this one out. So I give you the density of a solution. Density is say 2.53 gram per ml. And the volume we have used 200.1 ml. You have to determine the mass. So the mass will be, the mass will be what? Density multiplied by what? Volume, correct? So it will be density 2.53 gram per ml multiplied by 200.1 ml. ml with ml cancels out. So you have 2.53 multiplied by 200.1 grams. And the answer will be in grams. How many sig figs? Well, this is 3 sig figs, correct? 3 sig figs. This is 4 sig figs. So your answer has to be what? 3 sig figs. So if you multiply those together, you have to then round the whole thing off to 3 sig figs. So you can calculate this. I'm not calculating, but you get the idea just now. You multiply those together, and then you have to round the whole thing to 3 sig figs. That's the least sig figs, correct? So we are coming to slowly, just and now those sig figs. Okay, so now sig figs. Well, it turns out to be, if you allow me here, I'll Google. Let me take this one here. Everybody has first this one here. Everybody has this. Everybody has this? Okay, so I'll take this one out. I'm Googling worksheet for SigFix because this is about 2-3 questions about SigFix. As a matter of fact, we did all the SigFix, correct? So SigFix worksheet. We don't need answers, so we don't need answers. So okay, here it is. Okay, guys. If you look at this significant figure, I would like to download one. So let me see if we can get one downloaded. You see the let me see if this, yeah, that's the bad thing about Bing versus Google. Bing is so limited. Now, if I go for Google, you will see a lot of worksheets available to you, more than you can think about. So anyway, let me go for Chrome. If I get SigFix work sheets, see here, plenty of those, plenty. So they okay, and they are very good. So let me just do this one here. Can you see those? I can download them. I can open them here. Now, guys, if you look at this, I can add them up. Question is, you tell me about the SigFix. Let's do them quick. First one, how much? 5. Second one, how much? We are going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, how much is this? 6, correct. The other one, next. 4, the other one. 3, the other one. 4, the other one. 3, the other one. 5, the other one. 1, okay, very professional. The other one. 1. Why is 1? What's missing? The decimal. In order to be the zeros, you have two conditions have to be met at the same time: presence of the decimal and presence of the whole number. Okay, so that's 1. So how much is this? 6. How much the other one? No, the decimal is there. Come on, don't let me down here. How many? 5. And the other one? How much? Oh, somebody said 6. 3, and that's 6, yeah. So now, when it comes to add, we have to watch the, what they call it. We have to watch for the number of the digits. The least number of the digit will control the outcome of the rounding off, correct? So can I take this one out? Okay, let's see this one here. Okay, so do for me the calculation. How much is the value here? The first, this one here. We'll do just one example, and then you can look into this, like Google any secret. You have it in iCollege, couple worksheets in iCollege. So how much is the whole number here? You want me to do it? I will do it then. 32. I'm looking at this. Here it is. Make it bigger. Oh, you can't see it. Okay. Okay, so sorry about this. So now we'll do this one here. What's the value here came out to be? Well, I did the calculator here. I'll do it for you. So we have 32. First of all, we have, let me clean up the whole thing. 32.567 plus 135.0 plus 1.4567. The answer is 169. So the answer is one. Oops, sorry. Okay, so let me just hold on. That's the answer, correct? And I will have this one here. I'll cut it off. So copy, sub. Okay, let me take this one out of the. Anyway, so you get the idea. That's the answer here, correct? So now I can come and say, okay, let's put this one here. How many digits I have here? 3 digits, correct? Guys, how many digits I have here? 1. How many here? 4, correct? So which will be the winner? 1. So the answer is 169 what? No, 0. 1 digit. This is not 5. If it's 5, then I will round it to as 1. Make sense? Make sense, guys? So that's one example of subtraction is the same idea. So let's go back here and look at, let me take this here out and look at multiplication. So let's multiply select any one of those. Which one you like? E? This one here? Okay. I'll take it and make it. So here it is. Okay, so the answer is, somebody has it? The whole answer, how much is it? Don't me? I can do it for you guys. Don't worry. I can do it. So we have 43.678 multiplied by 64.1. Division is the same, like the same rules. So that will be 2,700. How much was it? 2,000. Maybe I'll do it here this way. How about that? So copy. Then I'll come here. Yeah. So that's the answer, correct? Now, if you look at the whole multiplication and division, I look at the whole sig fix, not digits after the decimal. But addition and subtraction, you look at the digits after the decimal. But here I look at the whole thing. So how many sig fix I have? 5 sig fix, correct? And how many here I have? So the winner will be the least sig fix. So I have to have 3. So now I have 2,799. 7598. How many sig figs I have here? So 4 and 4, that's 8 sig figs. But sig figs. I have this 8, I have to transfer it into 3. How should I do that? Somebody can tell me? Scientific notation, correct. Scientific notation, that's the way it is. Well, it's up to me and up to the answer of the multiple choice. I can move, whenever I move left, the exponent will be positive and the number will be shrinking. If I go to the right, the exponent will be negative and the number will be increasing. So decreasing to the left, positive exponent, and then to the right, negative exponent, and the number will be increasing. So let me just put this one here, maybe like this, 3 digits, for example. You can move it whatever the question, the answer, the multiple choices. So I will move it 3, so it will be 2, 7, 9, 9, 7, 5, 9, 8. How many I moved the decimal? 1, 2, 3. So it will be 10 to the left means positive 3. Okay, I need 3, correct? So I have to stop here. Everybody's following? However, this is 9. 5 and above is 1. So this one is the whole thing. So the whole thing will be 2, 8, 0, 10 plus 3. You understand my point? This is 27. It's 279, correct? This is 1. This is 1, 10, 10. So this is 1. The 1 will go to the 7. So 280, 10 plus 3. Make sense? So this will conclude the review for the whole final exam. 20 questions, 2 hours. You have plenty of time, so don't worry. You will be okay. Okay, so I will close the recording now. So, and I'll try to get this one here